using the Pythagorean theorem to find trigonometric ratios. All right, in a previous section, we talked about defining the trig ratios using a triangle and their side lengths. We talked about sqrt, and I might just kind of copy and paste, duplicate, bring this down, boom, erase, move. All right, sqrt, we talked about sqrt being how we defined the side lengths. So sometimes we have to do a little extra step here. Sometimes we have a triangle, but we don't have all the side lengths. Before in the problems we did, we had side lengths given to us. So let's look at one where we don't have all the side lengths given to us, and we'll solve it. We'll solve the trig ratios. So looking at this triangle here, we have angle theta, and opposite, we have 3. So opposite side is 3. Right next to it, and when I say adjacent, there's 2 sides that are adjacent to that are right next to theta, but one of them is the hypotenuse. So that's always going to be the hypotenuse. It's the adjacent leg is the leg that's next to the right angle and theta. This side over here, right next to theta, that's the adjacent side. So adjacent is equal to 8. The hypotenuse is what we need. So we need to solve for our missing side length, the hypotenuse, which we're going to use a squared plus b squared equals c squared. Really, it's c is equal to the square root of a squared plus b squared. That's how I'm going to write it. I'm not going to solve it all the way out this time, just because that's what it simplifies down to. So the hypotenuse will be the square root of one of the sides, 8 squared plus the other leg, 3 squared, the square root of 8 squared plus 3 squared. And as long as my calculations were right when I filled out this worksheet, it should be square root of 71. My hypotenuse is square root of 71. Now we just do the trig ratios like we've done before. So sine is opposite over hypotenuse. So sine of angle theta is equal to the opposite side 3 divided by the hypotenuse, the square root of 71. Soulmate is cosecant. So cosecant of theta, I'm going to skip the color coding here. Reciprocal is square root of 71 over 3. Now, some people will say that you can't leave your answer like this, and that's just not true. You can absolutely leave your answer like this with a radical in the denominator. Every once in a while, online programs won't accept it as an answer, but it's very rare. And the wording has to be there. So it has to say rationalize your answer in order for them to not accept an answer like this. So this is totally fine. And I think it shows us more about the triangle when I leave it that way. All right, cosine of angle theta. So ca, adjacent over hypotenuse. The adjacent side is 8. The hypotenuse is the square root of 71. Soulmate is secant. So secant of theta, that's the reciprocal, square root of 71 divided by 8. So just flippity flopping that fraction. Last but not least, we have tangent of theta. Tangent is opposite over adjacent. Opposite side is 3. The adjacent side is 8. So 3/8 is tangent. Tangent of theta is 3/8. Soulmate is cotangent. And the reciprocal of 3/8 is 8/3. Boom. That's it. This next one, very similar. It's just you're solving for a missing leg instead of a missing hypotenuse. So the formula for a missing leg, again, normally we would start with a squared plus b squared equals c squared, but then it would turn into eventually a squared is equal to c squared minus b squared, and thusly a is equal to the square root of c squared minus b squared. And I know we went over this in a video before, but just review it again. All right, so for angle theta here, the adjacent side is 5. The opposite side is our missing side. So I'm going to call this guy X. This will be our opposite. And hypotenuse directly across the triangle from the right angle is 6. Hypotenuse is 6. So to solve for X, right, I'm going to call X A. A is X. Maybe I'll make that just in black. A is equal to X, B is equal to 5, and C is equal to 6. So plugging that in, we have X is equal to the square root of 6 squared minus 5 squared, which is square root of 11. So we have that opposite side is square root 11. The adjacent side is 5. The hypotenuse is 6. I'm going to be a cheater McCheaterson, and I'm going to steal all of these over here. And boom. All right. So sine, again, opposite over hypotenuse. Opposite side is square root 11 divided by the hypotenuse is 6. Soulmate of sine is cosecant. Match the S and the C together. So cosecant of theta, the reciprocal will be 6 divided by square root 11. For cosine of theta, that one is adjacent over hypotenuse. So adjacent is 5 divided by hypotenuse is 6. Soulmate of cosine is secant. So secant of theta is equal to reciprocal of 5/6 is 6/5. Now you might think to yourself, and maybe I should have mentioned this earlier, that reciprocal means they're opposite signs. And what you may be thinking of are perpendicular lines. So a line is perpendicular to another line if their slopes are opposite reciprocals. Because that's one of the only times students talk about reciprocals, that tends to be when it tends to get kind of wires crossed. All right. All right, tangent, opposite over adjacent. So we have square root of 11 is the opposite side. Adjacent is 5. Tangent soulmate is cotangent. So cotangent of angle theta, reciprocal is 5 over square root 11. And that's that. So really, it's not any different than the problems we did in the previous video. It's just that you have to solve for a missing side length using the Pythagorean theorem. All right, well, that's it for this section, and I'll see you in another video. Bye.